It's a very water-sensitive region and also very politically troubled region where water is one of the factors that drives instability and conflict. So that's scary. What about hurricanes? I work a lot on hurricanes. So this is a satellite image of Hurricane Patricia. This was in the Eastern Pacific in 2015, and it was the strongest hurricane ever measured in the Atlantic or Eastern Pacific. There's some hurricanes in the Western Pacific that are believed to have been stronger, but didn't have aircraft fly through them, and this one we did. So this was measured by the NOAA hurricane hunters, so they know that this thing's winds exceeded 200 miles per hour because they were inside it and they measured it. So this is the kind of thing that gets reporters' attention, and they call and say, what does this have to do with climate change? And actually, that's a complicated story. So hurricanes is a case where things get more uncertain. So this is a graph showing the number of hurricanes. It's not just the number of hurricanes, it's the total hurricane activity in the Atlantic every year expressed as one number. So each year here on the horizontal, there's one blue bar, and the height of the blue bar is one number that tells us how many hurricanes there were, how strong they were, and how long they lived, all boiled into one number. And if you're interested, I can explain in more detail how we do that, but it doesn't really matter. And what you see is a lot of ups and downs year to year, and even over multiple decades, you see high periods and then a low period and then a high period and then a low, and then it's actually been kind of low the last few years. You don't see, an upward trend. I mean, if you thought that global warming should just make more hurricanes, you don't see that in the obvious way. You see a lot of what looks like natural variability. But this is just one measure, and we don't only have observations of hurricanes. We have, let's take a step back. You might look at this and say, there's nothing to worry about with hurricanes because they're just fluctuating up and down and there's no big trend. Another way of saying it, though, is there's so much natural variability that any low trend that's there is wiped out by it. Or if there was a trend big enough that we could easily see it on top of this kind of natural variability, if it was going like this, then we'd be in really big trouble, right? So we're not in that big trouble, but we do, but these are the projections for the future. So there's been a tremendous amount of research on what hurricanes will do under climate change. It was a pretty primitive subject about 15 years ago, but there's been a lot more research on it. Still a lot of uncertainty, but we know more than we used to. And our models have gotten better, and we've got more insight. So this is a couple of graphs that are a bit complicated, but I'll explain them, that summarize the state of knowledge from the latest IPCC report. And it's just for two basins. So the North Atlantic is where we live. That's where our hurricanes come from. And the Western North Pacific is what it sounds like. It's where the hurricanes, the typhoons come from that hit, Japan and Taiwan and the Philippines and all those places. So there's four numbers here, and each number is a different measure of hurricane activity. So one is frequency, is how many hurricanes there are. Category 4 and 5 frequency is the second number, and that's how many there are that are category 4 and 5, which are the most intense hurricanes that do the most damage. 3 is the lifetime maximum intensity, so without worrying about how many there are, how intense are whatever ones that are the most, the average peak intensity that each one reaches. And 4 is how much rain they produce. And so with each one, so it's all expressed as the vertical axis is a deviation from the historical average. So if there's, below, the 0 means decreasing and above means increasing, and the blue dark bar means what's our best guess, and then the uncertainty range is shown in the lighter color there. So just to take the Western North Pacific, the number of typhoons is actually predicted to be more likely to go down than up. Fewer typhoons, and actually the same for the Atlantic, but the uncertainty ranges are enormous, such that you could actually have more. The uncertainty range exceeds 0 by quite a lot. So a lot of uncertainty about frequency. We really don't understand what controls how many hurricanes there are in a given year. And in fact, we can predict some of the fluctuations, like with El Nino and things, we have some predictive skill, but we don't understand. The total number of hurricanes on the Earth in a given year is about 90, plus or minus 10, and we don't know why that number is what it is. We don't know why it's not 200 or 10 or something, so that you can sort of understand why it's hard then to predict the small changes due to climate change. And so that's why that uncertainty is so large. The number of let's look at the intensity, though. The intensity is predicted to go up with pretty good confidence. The Atlantic, maybe it could go down. This exceeds 0, but this one doesn't go below 0. So some small percentage-wise increase is a pretty confident prediction. We think hurricanes will get stronger. And that's because we have actually a pretty good physical theory. A hurricane is like a heat engine. So when Mike teaches, I don't know if he teaches freshman physics, you teach about heat engines and Carnot cycles. A hurricane is kind of like a heat engine. We understand how it's related to the sea surface temperature and the upper atmospheric temperature. It basically moves heat from the ocean up to the atmosphere and generates mechanical work, and that engine becomes stronger as the climate warms. And that's why it's not just a computer model thing. We actually understand the physics of hurricane intensity. That's why that's pretty confident. Precipitation goes up without question for the same reason as other precip extremes. There's more water vapor in the air. The hurricanes are good at wringing it out, so we get heavier rainfall. The number of category 4 and 5s, which is the second one, is quite uncertain because that's a mixture. I mean, how many strong ones you get is a combination of how many you have altogether and how strong they are. So we think they're probably getting stronger, but there could be fewer of them. So the number of category 4 and 5s is sort of a balance between those, and that's why the uncertainty on that is enormous. So that's a long, complicated story, but just to say there's different aspects of hurricanes, and some we understand better than others, depending on how much we know about the physics and how much, in the case of frequency, we'll really just rely on computer models, which are getting better, but we don't like to be, but they're still uncertain. So this is a summary of what I just said, based on what we expect. Frequency decrease maybe, intensity increase, and rainfall likely increase. So, let's take a step back. So when we see a hurricane like Patricia, because there's so much natural variability, and we don't really clearly see the signal of climate change in hurricane statistics yet because of all that noise. Even if it's there, we don't see it. Maybe it's not there, or maybe we just don't see it. But when you see a storm like this that breaks records for the most intense storm, we can say at least that's the kind of thing we expect to happen in the future more often. Because if they're all, if they're getting stronger, you're going to break records more often. So it's at least, a harbinger of what we expect, even if we can't pin it on global warming yet. But the last thing is, if you're worried about events like Sandy or Katrina or any of the other events that tend to be the biggest hurricane disasters are the ones where you have storm surge and coastal flooding. That's what kills the most people. If you think about events like that and you ask, are we going to have more of those kind of events in a warmer climate? The answer is definitely yes, and it's because of sea level rise. Hurricanes don't have to do anything. So this is a picture of the Jersey Shore during Sandy. You can see the ocean coming onto land. It's just the wind. The storm surge is just the wind from the hurricane pushing the ocean onto the land. And if the ocean starts off higher, then it just doesn't take as much surge to create a flood. So the surge in Sandy in the New York harbor and in the Jersey Shore was about 9 feet. That means the water was about 9 feet above where it would have been just due to the tide. So if you have 3 feet of sea level rise, to take a not such an outrageous estimate for 2100, it's now kind of a middle of the road estimate, 3 feet of sea level rise, then you only need 6 feet of surge to get the same disaster as Sandy. And 6 feet of surge takes a weaker storm. And weaker storms are more common than stronger storms. So you're just going to have these things more often with higher sea level, unless you raise everybody's house up, unless you move back from the shore or do something to defend against it. But with the current infrastructure, these disasters are going to happen more often, and there's no doubt about it, really. The only doubt is how quickly it happens. If I can change the slide. Okay, this is just, I showed you a graph of sea level rise before. This is a graph showing future projections. So this is the historical record. This is, again, centimeters here relative to late 20th century, early 21st century, rather. So this is from tide gauges in the red, and then we have satellite data in recent years, and that's blown up. It's quite amazing, actually. It's satellites with radars on them that can measure the height of the sea surface to within centimeters, millimeters even. And so that's about 3 millimeters per year recently. This is now an old paper. These were the projections from the second most recent IPCC report, saying that you'd get this amounts to a sort of a foot-ish of rise compared to present by the end of the 21st century. The more recent IPCC report has a range that's about like this, with a meter being the high end. And at this time, these authors who are experts on sea level, I'm not one, but they are, they had assessed the literature at that time, and the range of estimates from different experts went up to as far high as 2 meters, which is about 6 feet, and more estimates are coming in up here. So it's still, we still can't really say where in this range we're going to be by 2100, but we're definitely going to be somewhere in there. And these are big numbers compared to the kind of surges that hurricanes create. So again, Sandy's 9 feet, that was a big disaster. So numbers like 3 and 6 feet are huge changes. And by the way, it's very misleading that we show graphs like this stopping at 2100, because sea level rise doesn't stop at 2100. In fact, sea level rise is the last thing to happen. If you put the carbon in the air, climate takes a while to warm because the ocean's very big and heavy and it takes a while to warm it up. But then even once it warms up, the ice takes a while to melt, so the sea level rise is even slower. So you know, when we show, so we will have more sea level rise than this, without question, just maybe not that soon. The only question is how soon it happens. So now I just want to talk about the question I started with was, when there's a specific, everything I've shown you so far is sort of general trends. What can we say about the